Welcome back on our lecture series on module-free software design. We're already on our second part, the data design. So our goal for this whole module is for everyone to be able to capture technical information through modeling. So in context to the projects that you are proposing. So at the end of this lecture, so you should be able to con- uh, explain concepts related to data design and also construct software models for your prospective project. So we will be covering concepts on data design and also have an overview on the NoSQL best practices. So if you can still remember that we created different uh, diagrams, now we have our data dictionary, and all of these things will be used for our design model. So everything that we have created will be the foundation of this design model. And here we will be focusing on data design, which will be using our outputs in data dictionary and also the ERD. So uh, if you can remember your previous course on databases, so businesses, organization, so uh, in previous decades are primarily done using paper-based or manual operations. However, in the year 2000s, no, with the availability of computers and more modern technologies, so many businesses are shifting to digital and computerized operations. So, mind you, even now in 2020s, no, there are still businesses and organization which still uses uh, software, productivity software, such as Excel and other forms of spreadsheets software. So although there has been a push for creating information systems, no, uh, it is not particularly attractive for small businesses to really invest no, into software development because software is costly. So that's why they prefer these uh, ready-to-use alternatives that are provided by Google, Microsoft, no? So, however, if a certain company have extra funds, no, so they might opt to have their operations converted into a fully digital one, no, using a custom-made software. So, however, no, if you are solving a problem which is focused on transactions, so RDBMS is still the best option. So if you are into financial transaction, ordering, uh, billing, reservations, and other stuff, so there is no question. So relational databases are still the best choice. However, no, we'll cover other options as well. No, so uh, if your software is into streaming or into uploading data no, from users or such as videos, posts, and so on. So there is another kind of database that might be fit for those kind of data. So in data design, so basically this is just the selection of the logical representation of data objects. So basically we already have an ERD, no, an a normalized ERD. So in data design, we will be converting this ERD into a representation that is ready for use no in the actual software. So basically it's just the refinement and also uh, and maybe applying performance techniques that we will be covering in this lecture also. So in data design, so we use the conceptual ERD diagram. So the ERD is the representation of the actual operations, no, that is already happening or we expect to happen in a certain operation or in a certain business. So of course, our output would be a normalized relational database. However, that is not final. No, in data design, it's still iterative, so it's collaborative. It requires effort of multiple people, so including the client, including the analyst, not to really have this uh, model, no, that somehow sits between uh, the needs of the user and also in a way efficient when deployed into into the real world environment. So here we also integrate performance design. So now that we already have our normalized uh, database model. So we move into denormalization. So basically, if there are data that are frequently used, so we might duplicate it, no, on certain tables so that our calls to the database are not that too often. So imagine every time you refresh your web page or your app, no, so instantly you have 20 calls to that database. So compound that to, let's say, if you already have a 100,000 thousands users now accessing your application or your web service altogether. So that can cost cost you money, of course, no, since access to the database somehow also increases the cost that you need to pay for the services that offers your database. So now that we have covered, no, a very basic uh, knowledge, no, on moving from ERD to normalized database to performance uh, enhanced database. So we'll go into NoSQL best practices. So you might have heard online on uh, uh, since it's NoSQL, so we don't need data design anymore. So do you agree with that? So of course not. So no SQL does not mean that you no longer need data design. So no SQL was created for data that don't have strict schema, no, that are or certain data that or services that are evolving very fast, and your database need to adjust to this very different data that comes from uh, the users that interact with your system. So of course we still do data design. So it is still a crucial part, no, in all types of software development because poor designs lead to inefficient systems, and there might be problems with scaling in the future. So that's why uh, in data design, so we still create this ERD, we apply normalization, but uh, we integrate performance design, no, so that we can cater uh, the needs of the system in context. So it really depends on what type of uh, NoSQL database that you will be using for your system. However, no, we have this uh, somehow some best practices on how really to uh, technically plan no on which database to use and what things to do after. So first you need to understand your data model. So you look into your original analysis model, your original ERD, no? So what kind of operations are being done? Are these financial transactions? So are these data that are created by multiple content creators? No, it can be posts, videos, pictures, and these contents might be streamed no, by multiple people altogether. So that's why earlier I said to you that if it is more focused on financial data, so stick to traditional RDBMS. So RDBMS fully support ACID, no? So if you can remember ACID, so that's atomicity. So it's all or nothing. So if a portion of the transaction fails, no, so if you have multiple SQL commands being fired, no, for that specific transaction, if one of that operation fails, the whole transaction fails. So we have consistency. So RDBMS fully support consistency. So whatever rules that you have set, no, the data types, the uniqueness, the foreign keys, the constraints, and other things that you apply on your tables, on your and the whole database, no. So uh, those ensures consistency of your data. Then we also have isolation. So the transactions that run no, or being executed do not affect other transactions. So, however, we have modern systems already. We have modern RDBMS. So they have this different mechanism to avoid issues with uh, this lacking of database. No, so we no longer have to think about this complexity. So that is already handled by the RDBMS. Then lastly, we have durability. So all the transaction, all of the data that are committed already in the database. So those remains, those persist, no, even with calamities, even with crashing, no. So as long as the data was committed, so you expect that when you turn your system again, so those data persist. So that's why RDBMS now is really best for financial transaction. So on the other side, so if you are creating a very simple system, a prototype, so you can use a very simple key value pair database. So an example for that, no, we have Firebase, no, can create a very simple uh, JSON-like structures. However, if you are starting to create more complex uh, software, so you can move into document oriented. So you can still specify the general schema of your database, and uh, really it's just like a sets no of similar looking JSON files, which can be extended using IDs or depending on the service that you are using. So if you are into more complex type of data, no, because there are instances that uh, one user might generate data, no, for example, if we have Instagram. So if you're going to post in Instagram, so there are a lot of options. So you can actually you need to add pictures and caption, of course, no, but you can set music, you can set location, so you can set your audience and a lot of other features in just that post service, no. So you can opt for a column family, no, where your uh where your single row no can have uh, can remove certain columns, no. So unlike RDBMS where it is strict, no, so you just specify that this column can be null and so on. However, for column family, so it's a bit more different. So if that data no is not set, or if the data is not supplied by the user, then that specific column is not part of that specific row. So that's for column family. Then if you are into these complex relationships, no, such as social media, so you can use graph-based NoSQL type of databases. Then we have more modern one, no, for especially for use in AI, we have these vector databases. And there are services available right now which uh, somehow is a hybrid, no, of these different uh, types of databases. So again, to be able to choose which type of database, no, so you really need to understand the data model. Of course, there is this sad reality, no, nga we choose the database based on what is available in the market and what is somehow offering a free tier, no, because as students, it would be hard for us to fund ourselves to learn uh, different databases which are somehow very uh, pricey, no. So there are available resources right now, no, such as Supabase. So if you want to explore RDBMS, but with a touch of OOP, no, so you can use Supabase for your as a backend for your applications. So next is to define your schema. So anyway, you already have your ERD. So you have your maybe your data dictionary, no. So now you can just set the data types, no, for your basically for your primary key. It's just uh, primary key in, no, and so on. So it really depends on the database, no, how you set the data types, because it really differ uh, a bit on which type of database service that you are actually using. So since you already have an ERD, so there's no longer a problem with relationships, then you just need to role play a bit, no, to really see which specific uh, uh, tables, which specific fields are frequently being queried by certain features of your database. For example, if we go onto Facebook, so maybe the most frequently queried field, no, are the names, no, the profile photos, the contents itself, no, the likes, the comments. So basically that's how uh, Facebook starts, no, with their uh, data design. So they focus on which data are frequently showed or frequently consumed by the user. And our goal is using this knowledge, no, on the frequently queried fields, so we can always apply the normalization. So I uploaded another guide, no, on denormalization. It's not a part of this lecture. However, if you are into databases, and you if you are into improving your skills on data design, so you can download that PDF file and just go over the contents. Then, of course, although in NoSQL, no, it is not strict with the data that you feed into, or the transactions, no, that you feed into it. uh, you still need to enforce schema and data validation, so both in the front end and on the back end. So because if you're uh, if the security of your system is low, no, so user might abuse, no, your database. So for example, blockchains, no, so there are these very crude blockchains that just accepts, no, any types of serialized data, and the only limit is really the block size, no, or and the payload itself, no, there is a certain calculation on how much to pay, but you can't actually use or abuse blockchains, no, and use it as a crude database for your needs, no, that does not follow uh, the guidelines of that specific blockchain. So anyway, no, so enforce schema and data validation. So that's on the front end side, no, of your website or your apps, and also on the back end side. So next is design for scalability. So of course we intend that the applications that we propose right now are expected to be deployed. No, and we can't really tell for sure. Of, of, of course, we have uh, technical criteria that this is a good projects and so on, but we don't really have that prediction bang this specific application might trend might go viral, no, for whatsoever reason. However, it's really great that the services right now, no, are broken down into different tiers. No, we have this free tier or hobby tier where we are still starting to do our development, and if we think that our app, no, is already ready, no, so after a series of testing and now that we deploy our application, so there is just a radio button, no, nga, you allow you or you enable auto scaling. So for example, for Google Cloud Console, so basically if you max the limit, no, so you can choose to either disable the service if you max out your credits, or you max out your quota, or just pay based on the units that you are using. So it can be gigabytes of uh, bandwidth, or your CPU usage. No, so you can just set it in the settings. No, for this second part, so we don't have a special course for your CS degree, no, for distributed architecture. So this should be another subject, no, that's focused on this uh, more complex deployment. However, so certain databases, certain services, no, where we deploy our application, uh, which we can really set, no, nga, since my app is targeted to Philippines, now we can put or we can deploy this specific instance in Singapore, since it's the closest, no, the closest server in the Philippines. So of course, if you are deploying to the whole world, so that's another story. No, you need to learn a lot of other technologies as well, such as load balancer and other things. No, it can be very complex, no, to set this up. However, for small scale projects, so it would be enough if we just set our default server for example Japan or Singapore, whichever is closer to us. Then again, uh, it's still complex, no. However, as much as possible, no, if we can choose RDBMS again for our financial data, no, so we can use hybrid approaches for that. So for all that financial transaction that would be uh, uh, saved to our RDBMS, and if we have this contents, then we save it to our NoSQL database server. Then another one, so you can apply compression, no? So for example, for rarely used data, no? So you can actually compress those so that you can just decompress it whenever user might use it. Uh, this is a more uh, high level techniques now, but for our simple setup, so we can just go away for this for now for this specific project. So that's it, no? So I hope you learned a lot of techniques now for this data design. So it would really it is difficult to really tell you what to do in data design because we have these various types of database available, and the way you design your data model right now in this generation is really targeted not to which type of database that you will be implementing. So that's why we go into this high level best practices so that our knowledge would be flexible not to whichever database that we will be using. So in summary, no, so software design is just the translation of the requirements that we have analyzed and converting it into software blueprints now as designers that are necessary for implementation by the software developers. So the design concepts now are basically principles and guidelines. So they can be broken or as you gain more experience in the industry, so you might find things that doesn't apply to your scenario, to your context, to your company, to that specific project. However, these are the generic principles and guidelines that promotes structured and organized approaches into a clear and maintainable software design. So and also, so I'm repeating this again and again. So if you are deciding to which database to use, so prioritize our DBMS first. So they are best for consistency and and when the relationships of the data matters most. So we only choose NoSQL databases now if we have this application which is content hungry, no, where the operations, no, that's are featured in this application allows users, no, to really interact with our applications in a fast-paced manner, no. So imagine social media, streaming of movies, music, and so on. So those type of data can be modeled for NoSQL databases. Again, so for financial data, no, you can have a hybrid approach where you save this type of data into RDBMS. So that's all. So this is just a very concise slide. No, however, if you have ideas, no, that you think that should be included here, so please answer this evaluation form so that I personally can improve, no, to cater your needs, no, for data design. But I guess throughout my experience, so I want data design to be really generic so that you will not feel constricted, no nga, this is more focused on this technology, no, and this would not be applicable to other. So thank you so much. So that ends our slide on data design. Thank you.